Hello and welcome to Module 3 in our series SDL2 with C++. In today's session, our discussion is going to focus on the SDL Image library. Just a brief introduction to this library. So far, we've been working with the SDL Development library. The SDL Image library is also an extension library, but it works in conjunction with the Development library. The purpose of this library is to allow us as programmers to use different image formats in our code. The image formats that we could use, among others, include the .bmp format, PNG format, JPEG as well. Now, the beauty about this library is that it decodes the images of different types, thus freeing programmers from writing algorithms for loading and conversion of the different formats. Before we proceed, may I ask that you leave a like on this video, and if you're enjoying the series, then subscribe to the channel. This not only helps promote the channel, but also keeps me motivated to create more content like this. Thank you. Let's now take a look at some of the functions in this library that we're going to use in our project. The first function, ImageInit, and this is a function that is part of the initialization of this library. What it does is it loads the dynamic libraries required. It must be the first function called from the SDL image library. What it requires as arguments are what are known as ImageInit flags, and these indicate the types of images or the types of image formats rather that we will be using in our code. Examples of these formats that we could pass in as arguments include ImageInit JPG, ImageInit PNG, as well as others that are listed in the library. What this function returns are the flags that are successfully initialized, indicating again the types of image formats that we can successfully use in our code. If it fails though, it returns a 0, and if ImageInit fails, it is recommended not to proceed with using the SDL image library in our code. Let's now take a look at another function, ImageLoadTexture. This function allows for loading of image data into the GPU, graphical processing unit that is, or what is also known as video RAM. The arguments to this function include our SDL renderer type structure or the rendering context, as well as the path to the image file on disk. Now, what this function returns is a new texture or a null if it fails. Now, if you're wondering what a texture is, it is essentially image data that is stored in the GPU, or what is also known as the video RAM. Now, the SDL image library also provides us with what are known as SDL surfaces. And a surface, to put it simply, is a place or a region in graphical memory that we can draw on or draw to, right? In other words, we can store image data there as well. What then is the difference between a texture and a surface? Now, textures have their data stored in video RAM or the GPU. Surfaces, on the other hand, have their data stored in RAM. Now, because textures have their data stored in the GPU, we can use hardware acceleration here. With surfaces, we cannot use hardware acceleration. Remember, surfaces use the CPU. Now, textures being associated with hardware do not provide direct access to image data, and therefore image data cannot be modified easily. On the other hand, surfaces, because the data is stored in RAM, we do have direct access to the data, which makes modification easier. But when we talk about performance, because textures can use hardware acceleration, performance is going to be faster. With surfaces, because data is stored in RAM and we rely on the CPU to manage image data, performance is going to be slower. Remember, the CPU has many other tasks that it needs to handle, and so we are in a sense stretching the CPU to handle graphical data as well when we use SDL surfaces. Let's now look at another function that we're going to use in our code, and that's the SDL query texture function. This function allows us to retrieve or to query attributes of the texture or the image. It needs certain arguments. Of course, it will need the image or the texture to be queried. And once we've provided that, we can also provide pointer variables to retrieve, for example, the format. Now, in terms of the format, it could be any one of the formats that are defined in the SDL library. But to give you an example, there is one that is called SDL Pixel Format ARGB 8888. ARGB indicate the 4 channels alpha, red, green, and blue, and the 4 8s at the end indicate that each of these channels will occupy 8 bits of storage, which means that per pixel, this format will take up 32 bits or 4 bytes of storage. The next attribute that we could retrieve is the access, which indicates the type of access to the image data. It could be any one of the 3 types of access defined in the SDL image library. But to give you an example, it could be SDL texture access static, which indicates that our image data is going to change rarely. The other types of access defined in the library are SDL texture access streaming, which means that our image data is going to change frequently, or SDL texture access target, which means that the image is the rendering target itself. Now, throughout our series, we are going to be sticking with SDL texture access static, which means our image data is going to change very rarely. Now, if we do not need the format and access information, then all we need to do is to provide a null as argument for both of these to the SDL query texture function. The next attribute that we could retrieve is the width of this texture or the image, and this attribute is important, as we will see shortly. The next attribute is the height, again an important attribute, as we will see shortly. In terms of return value, SDL query texture returns a 0 on success or a -1 on failure. Now, coming to the next function, SDL render copy. This function allows us to copy either the entire image or the texture, or just part of the image or the texture onto our rendering context or our rendering target. The arguments to this function are all of these. The first one, we already know what that is. It's our SDL renderer type structure. The next one relates to the image or the texture, which is of course our image data. The third argument, source rect, indicates whether we want the entire image to be copied onto our rendering context, or we want just part of the image, defined by an SDL rect structure definition, which we'll come to shortly. Similarly, in terms of the destination rect, we need to specify whether we want the image to cover the entire rendering context or the entire window, to put it simply, or we just want it in a particular rectangular region, again defined by an SDL rect structure. Point to note is that the texture will be stretched to fill the given rectangle. What it means is that if we specify a null for the destination, then the image will be stretched to fill the entire window. So the image could appear distorted. If, on the other hand, we specify a particular rectangular region on our rendering context, then the image will be stretched to fill just that rectangular region. In terms of return value, SDL render copy returns a 0 on success or a negative error code on failure. And now let's talk about the SDL rect type structure. So to put it simply, SDL rect is a structure definition of a rectangular area of pixels. The origin of the rectangle is defined by the coordinates of the top left-hand corner of this rectangle. Now, if you look at the internal definition of the SDL rect structure, you can see the integer types x and y there, indicating the origin of this rectangular region, and then of course w and h indicating the width and height of the same region. Looking at the attributes now that we can set, that is the x coordinate and the y coordinate, or the origin of this rectangle, And then we can also set the width and height of this rectangular region. Where will the width and height come from? Well, remember with the SDL query texture function, we can query the attributes of the texture or the image, like the width and height. So we will set the width and height of the rectangular region represented by the SDL rect structure to the width and height of the image that we query using the SDL query texture function. Now coming to software requirements, there is a link in the description of this video. And if you click on that link, it will take you to a GitHub page. Scroll down the page and download this vc.zip folder. Extract the files into a folder and name it SDL Image. Make sure you do not extract the files into the SDL Development folder, right? This needs to be in a separate folder. Also make sure it is easy for you to access because we will need it for our project. Now, before we go, let's look at some code. So here we have our include statements. You can see we are including the SDL image header file, right? And then of course declaring our variables. You can see here we have ball texture, which is a pointer to a structure of SDL texture type, right? So that's the one we will use when we call image load texture to store our texture data. Then we have our window type variable. You can see here we have an SDL rect type variable and then our rendering context. We'll go straight to the main function and then look at each of these functions separately. So in the main function, first we're calling init SDL. So looking at init SDL now, we have a render flag set to SDL render accelerated and then calling SDL init to initialize the subsystems. Here we are calling image init, passing in those flags, indicating that we would like to use both JPEG format as well as PNG format. If image init fails, then of course we need to exit the program. And then creating our window. You're already familiar with this, so I'm not going to spend too much time on that. Right, so we're creating our window. If there's an error, we exit. Similarly, we're creating our rendering context. And again, if there's an error, we exit. Right, so that's it for our initialization. After calling init SDL, we're then using the variable we defined here, right, which is then going to store the return value of this function load texture. Looking at the load texture function now. So here we have a variable texture, which is a pointer to a structure of SDL texture type. Also note that this function is bringing in a parameter, which is the path to the image file on disk. And when we are calling this function, we are sending that same file as argument. So this particular file, for convenience, needs to be in the same folder as our project. So if I right click here and I say open folder in File Explorer, you can see the image file there. Now we're using this variable to catch the return value, if you like, of the function image load texture. Right? This of course takes our rendering context as well as the path to the file, which came as parameter there. And then we return that image data or the texture, right? So after the execution of load texture, ball texture will contain the image data. Now we're using the SDL rect type variable ball rect to set the origin of a rectangular region. And then of course calling set render draw color to set the color for our window. We have a while loop. Within that, we are calling render clear in order to paint the window as well as to refresh the frames every time render present is called. Check input. Now what is check input doing? Check input is checking for and pulling events from the queue using SDL poll event. I'm not going to go through that. I'm sure you're familiar with it. The only event we're checking for is SDL quit. If SDL quit is triggered, this is what will happen. Any other event will result in a breaking out of this loop. Right, so that's all for check input. It's pretty simple. Then we have a function blit that we are calling, which is taking as argument the texture data and then the origin of that rectangular region. So let's now look at the blit function. The parameters coming in are that same image data and the origin of that rectangular region. You can see here we have a variable, again of SDL rect type. And here we are defining a variable for the format and the access. Now here we are setting the origin of the rectangular region defined by SDL rect test to the values coming in as parameters here. These parameters relate to the origin of the rectangular region defined by ball rect, right? And as you can see, when we're calling blit, we're sending in the origin of this rectangular region, right? So I hope that's clear. And then calling SDL query texture, passing in the image data, and then passing in variables which are of pointer type. You can see we're passing in the addresses. Into these will go the format of the image and the access type. And then of course we need to also retrieve the width and height. So into des.width will go the width of the image, and into des.height will go the height of the image. Right? Now this is of course just for you to view the format and the access. And then we're calling render copy to copy onto the rendering context the image. We want the entire image, but where do we want it? In the rectangular region defined by the SDL rect variable dest. Okay, so I hope that's clear. Any questions, please post in the comments. Now, after we call blit, then of course render present to update the screen, SDL delay, just a minimum wait time there, and then changing the origin now of the ball rect structure definition, right? Here we are checking to see that the ball does not go beyond the bounds of our window. So what happens when we change the origin? Remember, this is happening in a loop. So blit will be called again with the new origin, right? And when blit is called with the new origin, we will set the destination origin to those changed values now, which means our ball will be drawn in a new position on screen. To put it simply, the ball will move, right? After we do that, we have our cleanup. You're already familiar with these three. Image quit will deinitialize, if you like, our SDL image library. And of course, return 0. So let's run this now. Right, so here you can see the ball moving, and of course it's bouncing off those ends, making sure it does not go beyond the bounds of our window. Now coming to the console. Format of the image is SDL pixel format ARGB 8888. You already know what this means. But what's the meaning of access type 0? So now if I take you to the library definition, you can see this is an enum type, which means 0 indicates SDL texture access static, and this will be 1, the other will be 2, right? So here, this is SDL texture access static. So I hope that's clear. Now, what if we change the code a bit? Instead of calling render clear here, what if we call it here, outside the loop? Let's run it and see what happens. Now, do you know what's happening? So essentially, because we're not calling SDL render clear within the loop, every new frame is trying to override the previous one, but remnants of the previous frame still remain on screen, right? And therefore, we need to call SDL render clear within the loop. So I hope that's clear. That ends our session for today. Till the next session, take care. Bye.